All right, guys. So, all of you are on Slack. Wonderful. Okay. It's the same tool, Slack, that is usually used in all real-world projects. So if you are comfortable with Slack, probably you'll find the same thing when you join any project. So I'm going to post the URL of our GitHub repository. If you see this repository, just let me see. This is the repository. You have your laptops open, right? Keep your laptops open during your sessions. All right. So this is the URL of your GitHub repository where all the documents are available. Usually, each technology that we work on is in a separate directory here. Ansible, AWS, Docker, GitHub, Jenkins and Nexus, Kubernetes, and Linux, which is what we are doing today. Then mini project related and Tomcat and Apache related stuff. Now, if you go inside each of these things, you'll find usually two other files. One is a workshop file, which you would do normally in the second part of the session. And the first one is usually the concepts part. If you look at the concepts, it lists out just a list of concepts that are usually discussed, for that particular technology. And then if you see the workshop, this is the workshop document, all right, where all the tasks are listed, and these are the tasks that you are actually working on during your 8:30 to 10 o'clock sessions. All right. Most of these documents keep getting updated from time to time, but usually this will give you a general outline of what is happening in the session. All right. So for now, we have started with Linux. These are the various commands like we talked yesterday that we're going to talk. You were also given a sheet, I think, yesterday. All right. That's an exhaustive list of Linux commands that you will ever need for a DevOps engineer. So ideally, you're expected to remember all those commands, be able to execute those commands with ease. All right. Now, these commands, it's not really necessary to discuss all these commands right now. So what I'm going to do is, I'm going to divide this list of commands into two sections. So we'll finish one section now, the essential ones, and then after about 10 days into our course, we'll finish the remaining ones. All right. Most of these commands you will come across in the workshops. You will understand why we are using. You'll get a context of it. All right. Right now, I'll just explain the theory so that you understand the basics around it. Now, if you look at these commands, they are divided into categories. General commands, files and directories related, archive related commands, process related commands, network related commands, then users, groups and permissions related ones, remote systems related commands, then variables and scripts related, redirections and some other commands. All right. Now, while we are discussing these things, we'll compare it with our Windows working, because we all know Linux is not doing anything different than what you want to do in a Windows system. All right? So whatever you would like to do in a Windows system, the same thing you would want to do on a Linux system also. So the first set of commands, I'll write it down again here. So we were talking about host name yesterday, then ID, I think uname, -a, then that's all. df-h. All right, keep it that. Now let's come to commands related to files and directories. There are 5 operations you perform on files and directories. You create them, you edit them, you rename them, then what do? You copy them, all right, and then you delete them. Those are the 5 operations you do on files and directories. We're going to see those commands. Create a file, not cat, touch a file. A file name, let's call it F1. That's how you create a file. Touch the file names, all right? The same way for directories, mkdir d1. Whenever there is a file, it usually we represent it using F, F1, F2, F3, F100 kind of thing. Directories D1, D2, D100 like that, just for the sake of easy understanding. So here you're creating a file using a touch command and making a directory using D1. You can create any number of files here and any number of directories here in a single shot. Now, if you see this thing, it will create a directory D1, D2, D3 at the same level. Now, sometimes you may want D2 to be inside D1. All right, you are creating a path like a tree. All right, in that case, you will give a path. You want a path -p. These are the 2 most common commands you will need in directories creation. File, this one. There's another command, you can create a file cat redirection F1. It will open a file F1, it will allow you to write things, line 1, line 2, line 3 like this. Then you close it using Control D, save and close. These are the 2 most common ways to create files. There are other ways, but these are the usual ways to create it. Alright? Touch and cat. mkdir with a P if you want a tree, without a P if you just want everything at a single shot. Alright? We'll see it quickly. So I'm opening another terminal. This is a tool, MobiXterm. You can also download it. So I'm opening a Ubuntu session. Alright. Clear is a command to clear your screen. That's okay. pwd is another command, present working directory. Let's see some quick, very simple commands. Date we have seen, right? pwd will give you the present working directory. It's also called current working directory, cwd I think in Windows, but pwd is a regular Unix model. Then cd, change the directory to anywhere you want. You want to go to temp, cd to temp. You want to go to root, you go to root. You want to go anywhere else, you just give the complete path. Alright? Very simple stuff. Now in cd, you will see two notations. cd dot dot. That is the parent. In a Unix system, it starts like this. This is called root. Alright? Then the file system is like this thing. So user has been home like this. Then you will have D1, D2, D3 like this one. So when you say CD root, you are here. Now from here to here, let's say you say CD root has been, you are here. Now if you want to go back here, what would you do? CD dot dot. Anywhere, when you say dot dot, you are going to the parents. So cd dot dot here, you go here. Dot dot here, you go here. Dot dot here, you go here. Then you switch somewhere else. It's a very simple puzzle kind of thing. You just move around with steps. Alright? So either you can give the complete path to go wherever you want, or you can run a lot of cd dot dots and move around. Alright? So that's your CD. Let's get back here. So here we're talking about creating the files. I'm going to create a directory here first, mkdir, let's say Linux, alright, CD, Linux. How do we create a lot of directories? mkdir, d1, d2, d3, alright. Now once you create it, you can't see it. That's the problem with Linux. Normally on Windows, if you double click a directory, you see the contents automatically. There are actually two commands you are executing. Get into the directory, show me the contents. Unix does not do that. If you say get into a directory, it just gets into that directory. It does not show you the contents. To see the contents, you have to list the contents, ls. Now a simple ls will give you just the names. You want more details, long list. You want also the time limits. And usually in reverse order, in human readable format. This is a common command. Let's see what it means. So I'm going into a directory, the same directory here, alright, mkdir d1, d2, d3. Let's say ls-l long listing, time based, reverse, human readable format. It will give you 9 lines. You're interested in the first and the last line. The first one, -d, are the details that the last thing is a directory. Alright? You're seeing D1, D2, D3. These are things you created, right? How do we know this is a file or a directory? You look at the first thing. You will see commonly two things on the first character, either a D or a hyphen. If it is a D, the last column is a directory. If it is a hyphen, the last column is a file. Alright? So when we touch something and do a ls-ltrh. What is this thing? This is a file, right? Which means for this F1, if we do a ls-ltrh, we should see a hyphen. What? Following along with me? I'm going a little fast, but pay attention. Alright? So if you see files, they are hyphens. If you see directories, they are Ds. So when you run your ls-ltrh command, you're looking at the first column, immediately your eyesight goes in here, and the last one. The remaining data in between is used sometimes and not used at other times. But let's see this. These 9 folders or these 9 letters you are seeing, RWX, R hyphen X, R hyphen X, they are permissions. We will talk about permissions in a moment. This is the user ID which owns that file or directory. This is the group that this user belongs to. Alright, don't worry about it right now. This is a file size or a directory size. All directories are usually always 4K only because Linux does not show the contents of the directory. It only shows how much space D3 is taking, that's all. If you want to see the overall size of a directory, there is another command, we will talk about it. But files, we will see that. And then this is a timestamp when it is modified. Right now, it is modified at 7:23. You can look at the date. I should reflect about 3 minutes before. All right. So what we did is we created a set of directories. We see in the properties of those directories using the ls-ltrh. Now you have to remember that ltrh. You will remember it because you will be typing this command 100 times or 200 times a day. Every time you go into any directory, the first thing you do is ls-ltrh. All right. Now let's go to files. Touch F1, F2, F3, F4, any kind of files, or F100. All right. To see that ltrh. You see the files now. So the first ones are directories. How do we know it's a directory? A D. The last ones are files. How do we know it's a file? The hyphen. All right. Now, if you see the files, the size is all 0. They are 0-byte files because we did not put anything into it. So that's just touch. Now, the other way to create a file is cat redirection. It's not called greater than, it's redirection. Cat F10. All right, let's say I'm creating F10 file. Now, cat command allows you to write content into it. Now, you are given a prompt where you can write content. So, line 1, line 2, line 3. How do I close the file? Control D. Now, your file is ready. ls-ltrh or ltrh. Now, if you see this thing, F10 is 18 KB or something. Now, you want to see the contents. F10, let's say you want to see the content. Cat again, without the redirection this time. F10, you see the content? So, cat is used for 2 things. One is, you are creating a file if it doesn't exist, or you are looking at the content of the file if it already exists. This is the most common usage of cat. So any file you want to see the content quickly, you just cat it. This kind of option is not available in Windows regularly. There is a command, but it's not generally used. Right? In Windows, if you want to see the contents of the file, you have to open it in a notepad. But notepad is an editor, which means accidentally you can put in some content into it. Whereas cat, we are not opening the file at all. There is no chance that you will edit the file. It will just throw whatever is inside F1 onto your screen. All right? So that's your quick cat, and let's do that directory also, mkdir. This time, let's do a path. Let's say D5, D6, D7. Now, see this thing. This is slightly different than what we did earlier. Earlier, we did D1 space D2 space D3. We are asking for 3 different directories in the same location. Here, our requirement is different. We want D5 to be created. Inside D5, we want D6. And inside D6, we want D7. So we need a path. That's what we're asking here. All right? So again here, if you do LTRH, here you will see only D5. Where is D6? It's inside D5. How do we go inside D5? CD D5. Change directory into D5. Again, LTRH. Here you have D6. How do we know what type of file it is? It's a directory type file. Then inside D6, CD, ls-ltrh. We have D7. Do we have anything inside D7? Nothing at this point. So this should be empty. We don't have anything. Right? Any questions? Perfect. So that's about creating your files and directories, navigating those files, seeing the contents of a file. All right? Now let's see the editing part. Do we edit a directory? Do we edit a directory? Can you edit a directory? Not the renaming part. What is editing a directory means? A directory is a group of files or other directories. So either you keep the files or you remove the files. That's all you do with a directory. There is no contents of a directory. All right? Only the files are contents. So editing of a directory logically is not possible. Editing of files is possible, isn't it? You open a file, you change the contents of a file. There are 2 options for this one: nano, vi. These are the 2 tools for editing the contents of a file. So you say nano f1, the one that you created, or vi f1. Vi is the old one, nano is the latest tool. Vi does not follow your arrow keys. This is the old style. L, K, J, no, L, how is that? L, K, J, H, I think. So that's your left, right, top. It's anti-clockwise. This, yeah, this. I think somewhere here. You look at your keyboard, you'll see these keys on the second row. Now, if you are not comfortable with this thing, you can use nano. It works like a notepad. So you open a file using nano. Let's go back to the file we have created. cd dot dot. Where do I go? Let's see this. pwd is currently I am at /home and code IT Linux D5 D6 D7. That's the whole part. Now I want to go to Linux directory. What should I do? cd dot dot. Where am I now? Under D6. Dot dot again. Now I am D5. Dot dot again. I'm under Linux, right? Perfect. pwd, you're under Linux. Alright? ls-ltr h. Sorry. J. Alright? So these are your files. Where are you? pwd. You don't have to remember anything. Just execute a command when you need something. Alright? So here, let's look at the path. F10, this is where we have some content. Cat F10. What it does, shows the content of a file. Now I want to edit it. Alright? Edit it. So nano F10. It opens a file. Alright? Your help is here at the bottom. You see here, this is all help, the one that is highlighted at the bottom. Alright? So here, now I want to go to line 3, change this 3 to 30. Done. Just like Notepad. You use arrow keys, come down, change whatever you want. Now in a Notepad, what would you do next? You edited it. Then what would you do normally? Save and exit, right? What are the commands for that? Control S, save. Control X, exit. Same thing here. Control S, I'm pressing. Control S. Oh, sorry. Here, Control S, right? You see this thing? It wrote 3 lines. That's your saving, writing. Then Control X, that's your exit. Last one, bottom. You see this? Left bottom, Control X. You're out of the file. Now you want to see the file again. Contents cat F10. That's cat. So I looked at the content of a file using cat. Then I opened the file using an editor. I edited it. Then saved and exited out of it. Again used cat command to confirm that the edit was done properly. Alright? So you look at the content using cat, then you use the editor and edit everything. Then you get back and confirm your editing using cat again. That's a general 3-step process you always do to make sure your edits are correct. Again, cat F10, right? Very good. So ls-ltrh, something changed here, see? The size has changed. Earlier it was 18, now it's 19. And timestamp also changes. Alright? The current timestamp right now, it should be around 35. So that's what you're seeing here. Alright? Now VI, I don't think you need it, or we will talk later. So for now, for the essential part, just skip with nano. Edit is done. Rename. Rename is called move in Linux and Unix. MV, file 1 to file 100. So you are renaming F1 to F100, just like Windows. A directory, same thing. Move D1 to D100. This one, slightly a variation is available. If D100 is not there, D1 will be renamed. Let's say there exists a D100 directory already. The D100 directory is already present. In that case, this move command will move it inside D100. Alright? So, when you are moving something, check whether your destination is already available or not. If it is not available, this is a rename. If it is already available, you are basically moving the current directory into another directory, inside another directory. Right? So basically it forms a tree. It happens like this. Alright? That's a very essential basics of move command. There are other variations, but you don't really need them. This is more than enough. Copy. This is a very common thing that you would be using. Copy file 1 into file 1000. So F1 will be copied into F1000. So you have 2 copies now. Now the same thing, copy directory 1 into directory 1000, but you have to say recursively, -R. Recursive copy means D1 and all the sub contents of D1 copy it into D1000. So if you have like this D1, D2, D3, let's say it's your original directory. Here D1000, D2, D3. The same structure gets created.
It gets renamed.
Sorry?
It gets renamed or it totally.
It's copy. It's copy. So you have this directory and this directory also. Both. These are copies. This is move. When you do a move, the original one does not exist anymore. When you take a copy, both exist. This one, your original one, and the copy also, both exist. Alright, and finally your delete. Delete is called remove, rm, file 1, file 2, file 3, file 4. Any number of files you can delete in a single shot. The same way here, if you want to delete a directory, same command rm d1, d2, d3 recursively -r. This is the difference. Just like copy command, rm command -r. Here you don't have to give -r. It's a single file, flat file. This is a directory. So everything under d1 will be removed, under d2 will be removed, under d, along with this d1, d2, d3 also. Let's run it quickly. So here, let's run a quick copy command first. F1 to F1000, that's what we did. Yep, F1000. F1 command outcome. You see, we did not do a copy. CP, we did not give that. We tried to execute a command F1. Linux says there is no command F1, which is correct. So copy, that's the command I want to execute. File 1 to F1000. Alright, list it again. So you have F1 and F1000, both are files. The same way, we want to create a directory. Copy D1 to D1000. Let's see what it says if you don't give -r. What does it say? Cannot specify omitting directory D1 because it's a directory. So copy recursively D1 into D1000. Now it works. ls-ltrh. You should have both D1 and D1000. Alright. Next thing, remove. Alright, let's execute a remove command. Let's remove F1, F2, F3, F4. RM, F1, F2, F3, F4. Do we have F4? Yeah, we have F4. Alright, so everything removed. Let's check it. They're gone. Your F1, F2, F3, F4 are gone here. They are not available here anymore. Now the same way, remove the directories rm-r, d1, d2, d3. I'm removing. Alright, gone. rm-r. Last command. ls-ltrh. Gone. You see the same set of commands I keep on repeating. Nothing changes much. So if you keep working for 1 hour in a Linux system, you pretty much know all the commands. The same list that you keep executing again and again and again. Alright, clear? PWD, we're at Linux. So that's related to your files. Any questions here? Let's summarize. How many operations we do? 5 operations. You create them, you delete them, in between, you edit them, copy them, rename them. That's in between. Beginning and in between. Alright? Now the beginning of the files is either using touch or cat. Alright? Then directories, mkdir. The end is remove. rm files, rm-r directories. In between, you edit the files using nano. You don't edit the directories at all. For copy, cp, cp-r for directories. For renaming, move file 1 to file 1. There is no move -r. You don't have to do that. Directories also get moved with the same move. Right? Only 5 commands. Most of the times, this is more than enough for your survival in a Linux system. That's what you would be doing on a Linux system. You open a configuration file, you edit it, you save it, you close it, you're done with it. Then you rename the files, you copy files from somewhere to here and there. That's a general process. All right? Let's move on to the next section, category, archives and compress. Let's compare it with Windows. What's an archive versus what's a compress? I'm looking at the list of commands. I'm following the same set of commands here. archives and compress. What's an archive? Forget the compress part. Look at an archive. What's an archive? Go ahead, answer it. Don't look at me like that. It's not a seminar. Archive.
Something happened.
That's correct. Means in a way it's linked. Archives are the places where history is stored, usually used in libraries. That's a word. Yeah, that's you're almost there. Good. So archive is a catalog of a lot of things. So if you have, let's say, a directory structure, D1, D2, D3, D4, I'll take it off. Let's say you have this D1, D2, D3. This is the directory you have. Now you want to transfer this file somewhere else, this whole structure. The easiest way is this. All right. Let's say you did a copy. There was a problem during the copy. This did not get copied. All right. In this directory structure, there is no way to know that this did not get copied. Let me give you an example. Let's say you have a bunch of sticks lying around. You want to move these sticks from this place to that room. What's the best possible way? Bunch of sticks lying around here.
I did.
Correct. You tie them up. That's your archive. So you put things together so that you can easily transport it from one place to another place. Now the major difference here is, does such a grouping activity, does it give any compression? Does it reduce the size of that lot, or it doesn't? Same sticks, you just bundle them together. Does it reduce the size? Does it? You're just tying it up. The overall size of the bundle is equal to the sizes of sum of all the sizes. It does not compress. So archive is slightly different from compression. If you look in Windows, you might have used zip command or zip7zip, or earlier it used to be winzip. Now winzip is a compressing command. Means if you have, let's say, a 100 MB file, text file, and you give it to zip, it compresses it and brings it to 10 MB. So you have a reduction in size. That is compression. Now compared to a compression, archiving does not compress. Archive is simply bundling it. So here in Linux, there is a very popular command, tar, tape archive. That was the original name. What it means is, if you have a directory structure and you want to convert it into a single bundle like thing, so that it's easy for your transportation, you can use tar, create an archive file. Let's call it t1.tar for the directory d1. That's your archive command. This does not compress. So here, look at the syntax. Tar, create a file. F should be followed by the file name. That's a restriction. And here, D1. Now this is slightly different from your earlier commands. Copy, source, destination. That's the general syntax. Here, tar, this is destination, this is source. For this reason, this command always gets asked in an interview. And this is also a very popular, commonly used command. So what we are doing here, you are bundling a directory structure into a single file. Now you can copy file anywhere you want. Now that you bundle, you also want to compress it, right? So that it's easy. That's your next command, zip d1.tar. This is also slightly different. Zip d1.tar into d1.tar.zip. Zip destination source. This file gets created. Now, why do we give the .tar.zip? Is that mandatory thing or it's convenience? It's not mandatory. It's convenience because let's say you give this file to somebody else. They have to unzip it and then untar it. So unless you give .tar.z, let's say you gave it like this, they don't know what command needs to be used on this thing to see the contents. The other person should know how. Let's say you gave a file, file1.pdf. When you transfer it to somebody, they know, okay, I have to use a PDF reader. If you remove the extension, you will not be able to understand what kind of software you need to read the file or use the file. Like .mp3. Let's say you remove the .mp3 part.
If you won't give the command, then it won't open.
It won't. Then you won't be able to open it, right? Obviously, you want to use the file somewhere. You've taken a tar file, you are transporting it somewhere else, then again you want to untar it and recreate this directory structure. That's the purpose you tarred it, right? So d1.tar.zip. The extensions are usually optional things, so that when you have this such a file, you know what to do with this thing. In this case, so you have a tarred file archived, then compressed. Now let's say you got this file. What would you do first? You would remove the zip using unzip your file d1.tar.zip. When you run this command, you get this file. This is a tar file. From this tar file, you want to get back this directory structure. That is, extract the tar file. Tar instead of C, X. Extract the tar file d1.tar. Now it creates the whole directory structure. So what you did, you created an archive, you compressed it, then you took this tar file somewhere else, wherever you want, using a pen drive or some other mechanism. On the other system, you removed the zip using unzip. So you basically uncompressed it first. After you're uncompressing, you untarred it. So you're looking at 4 commands. Tar, CF, and XF at the very bottom. In between, you have a zip, unzip. Right? The first and the last commands are archives. In between is your compression. So you are compressing, you are archiving, and then compressing. So you will see a lot of files with this extension .tar.zz files. So in this case, let's say d1.tar.zz. Now just like zip, there is another command, zip, that is open source zip command, unzip, that's called gunzip, usually same as zip command. When you use gzip, you give a .zz. Alright? So you are looking at archive and compress. Let's quickly run it. Let's archive something. D5 is a directory structure, right? There's a command called tree. You can see the whole command directory structure, tree D5. Tree is not there in this thing. I'm installing this command here, sudo apt install tree. The apt is the installation on Ubuntu. Sudo is a command to switch to root user because only root user can do the installations. We'll talk about sudo later, but right now I'm switching to root using the sudo part, and then I'm using an installation command apt, and I'm using the command here. Tree is the command that I want to install. Now this command connects to the internet Ubuntu repository through the internet and downloads the software required for tree command and installs it on the system. This is a very common command. Now this is a password. It's asking me to switch to root. Give the password. Now it connects to the internet, downloads everything, and it tries to install. Let's see. Alright, that's install. Now let's run the same tree command again. Tree F5. There's nothing in it. There's nothing in tree F5. There's nothing in F5. Did we not create D6 in it? Oh, that's F5. Sorry. We want to see the tree for D, right? D5, right? There won't be any tree for a file. There will be only a tree for a directory. See this thing? So D5, D6, D7. That's your tree. Now let's look at a much bigger directory. I'm going into /sbin. This is a directory of the system bin directory. There will be a lot of files in here usually. LTRH if you see. A lot of files. I'm going to run a tree on sbin. Tree/sbin. You see the tree? It basically gives you how this directory is set up. Right? These are all the various files. Again, coming back to our Linux, CD Linux. Now again, if you don't pass any parameter to CD, it comes to the home directory. Home directory is this thing, home encode.it. This is usually set up by the administrator when they create the username, which is part of Linux administration. So CD, so here I am. If I do a CD, wherever you are, if you do a CD, you'll always get back to home directory. Let's say here you are, CD temp. What's the directory now? /temp. If I do a CD, enter, where am I now? The home directory. Alright? That's also an easy way to navigate. Let's do a zip and extract the CD Linux. This is our directory we're working on. tar cf d5.tar. That's a tar file we want to create. Further directory tree d5. Alright? You have a d5.tar file. Now you want to compress it. Zip d5.tar.zip. d5.tar. That's compressed. 99% compressed it is. Deflated means it's basically compressed. Inflating is expanding. Right? A balloon inflates. Deflating is compressing it. So here if you say it got a 99% compression. Look at the size again. You have both files. This is 10 to 40 bytes. This is 284 bytes. These are two different sizes. Now this file you can take it anywhere. Let's say we simply take it to temp directory d5 dot okay. Copy this file. I'm copying. You can copy it into other systems, or I'm just copying into the same system into /temp. This is a file. I'm copying it into a directory this time. It's not like cp f1 f2. This is slightly different. Copy a file into a directory. Alright? Slightly different. Copy. Done. Let's go to cd temp. Let's see the file structure. So you have the file here. Now what you want to unzip it, and then untar it. Unzip the zip file. Right? What it does? It inflates. It unzipped it. Alright? So now you have your unzipped file. Now you extract or untar it. Tar except d5.tar. That's extracted. You have d5 here. Run a tree on d5. You have the whole directory structure. What did we do now? We took a directory structure, we archived it into a single file, compressed it to reduce the size, transported it somewhere else using copy, unzipped it to inflate it again, extracted it to recreate the directory structure again. So that's how you recreate the directory structures of one place at another place. Alright? Tar it, compress it, transport it, unzip it, untar it. Any questions in this? What are the next set of commands we have? Process related commands. Let's try to quickly do that thing. What are the process related things you do in Windows? Where do you see all the process in Windows? Task manager, that's correct. So whenever your laptop is usually slow or stuck, right click, task manager, you'll be able to see all the process running on your system. So let's do the same thing here. So I'm doing a right click here. Don't think you can see that. Right click, yeah, task manager. That opens your task manager. All right, more details. These are your process. What are the main things you look in this sheet or this window? You look at the CPU. That's the overall CPU usage on your laptop. Then you look at the memory. That's the overall memory usage on your laptop. Then the disk usage at this point. This is not a disk space. This is just really disk read write you're looking at. Then network, how loaded or unloaded. Network is your Wi-Fi we are talking about. Alright. Then GPU, this probably you won't see it or you will see it depending on whether you have a GPU or not, like graphical processor, NVIDIA or anything. You are usually interested in the first two things. On the left side, the first column, you see the names of the process. That's it, right? Then what you do normally, let's say you don't want the Chrome, you select it, you end the task. So you're listing all the process and you're killing things that you don't want. That's all you're doing. This is what it is. PS-EF. List everything. Kill -9 the process ID. These are the two common things that you do, just like Windows. So here, again, you want to see all the process running on your system. PS-EF. You're interested in the last column here, the command. That's your process. Right now, you just executed this command. That is also listed. That's the command you executed, right? Every command you execute is also a process. This time. Now the bash process you are looking at is the black screen you are seeing. That's called bash. And also there are other processes, WSL connect and other things. So I'm going to create a process. Yes, I can hear. Let's try to kill this process. This is a command. You are interested in the second column, PID. It's called PID, process ID. Kill -9, the process ID. Alright? So I'm going to kill the bash process here. The bash process is the screen. So when I kill it, the screen will go off usually. That should happen ideally. So kill -9. What's the process ID? 11. Alright? That's gone. Basically, you kill the process. Alright? I'm launching another process. Your session is basically a process. I launched another process. Again, if you run a ps-ef, this is another bash process. What's the process ID this time? 1108. So every process in Unix has a process ID which is unique. The operating system allocates it. Alright? So you list all the processes, you kill all of the processes. Apart from this, free-m, this will give you all the RAM available on the system. Top is the task manager you are looking at. An improved version of that top is human readable top. H-top is the latest one. Top was the original Linux task manager. So top. This is the same thing you will see on the task manager. This is the same thing. This one on Windows, this one on Unix. You are looking at CPU and RAM. This is your CPU. And this is your memory. This system has 6 GB memory. Out of that, 5.9 is free. About 82 KB or MB is used. Right? Don't worry about all the data in this one. You are only interested in memory usage, total, free, used. The same way, CPU, the load, there is no load at all, 0, 0. Means there's nothing running on this Ubuntu system. Only those two things you're seeing. This is a list of processes running on your system. Alright, now to come out of this thing, Q, you're out of it. H-top gives a slightly better version of this thing. It also shows all the processes, each process. These are cores. There are 8 cores. So you have 1, 2, 3, 4, 5, 6, 7, 8. How much each core is occupied, that's what you're looking at. And the memory. This one you will see the total here, I think. I can't highlight it. You can see that, I think. Yeah. Out of 6 GB, 82 MB is used. All right. Now the reason why we are talking about 2 is htop may not be available on all the systems, whereas top is a native command, so usually available everywhere. Htop needs to be installed separately. So you use htop, preferably, it's a better one. If it is not there, the basic one. Both commands, you press Q to quit out of it. Alright? Again, free-m. You saw the memory in top. This is also another command. Free memory in MB. This is total 6214 MB. 81 MB is used. 5921 MB is free. So that's how you see whether your RAM is completely occupied or you still have enough RAM on your servers. This is the same thing you are doing on Windows also. Nothing different, right? Only thing is you are using commands here. Couple of other commands, CPU info, that we'll talk later. I don't think I can finish everything today. Let's look at network. What do you do related to network in Windows? Well, you'll see you are connected to Wi-Fi or not. You'll see you are connected to internet or not, so that Wi-Fi. Anything else you do? Here, I think you are doing the only thing. So you are connected to internet or not. All right. To see whether you are connected somewhere to the internet, ping google.com. A ping command will send a packet over the network to any command or any website you give. You can give a website or a IP, any IP. When you send the ping, if that system is available and reachable, it will respond back. It's not like human beings. They do respond. We don't respond sometimes. Let's say somebody is calling your name, you don't respond. Systems are not that intelligent. So systems are designed to respond when somebody calls for it. Let's say I'm calling for Google from this system. Where am I? Sorry. Ping Google. Now the Google is responding back. It sent 64 bytes from this address. That's the Google address at this location. Now if you are pinging from some other location, probably you will get a different IP because Google has a lot of servers. Alright? But what we are essentially trying to do is, Sampurna, charge it. You're sending a ping to the website and you're getting a response. So I'll send something to the outside this network. Now I'm sending something to the within this network. There is a server 192.168.12.2. This is a router IP. You're connected, all of you are connected to your router over there. I'm sending a ping to the router. The router is responding back. Router also has IP. Alright? So when you see a response, it means the other system is available in the network. Now, if a system is not available, let's say I'm sending some random packet to a random this thing, 200, I don't know whether it exists or not, you don't get anything at all, which means that system is not reachable. Destination host unreachable. So the ping command tells you whether your destination is available or not. A similar command you will see IP to see the IP, small letter, sorry, IP A. It will show you the IP address of your system. Sanampurna charger. IP A. IP address. So here there will be a lot of IP address. Usually one of them is the correct one. Which one is the correct one you don't really know. So I'm looking at this. Okay, sorry. So I executed the command IP A. Thank you. IPA. I'm looking at the INET part here. You see this INET? That's your IP. There'll be a lot of INETs, but we are interested in only those things. So you're looking at LO, bond 0, dummy 0, ETH 0. These are your network interface cards. The card where you plug in your RJ45 jack. This wire you are looking at, this jack is RJ45 jack. The network port is the Ethernet card that has a name. So here in this case, it's 0. That basically represents this hardware port. That's the name. Alright? Now that hardware has an IP associated with it. That's this IP. That's how systems are named. There is a hardware, that hardware port, NIC it's called, Network Interface Card. So you have names for the NICs. ETH0, Ethernet, that is. Ethernet is basically, this LAN cables are called Ethernet cables. So for you, what you are interested in is the name of the NIC or the network interface card, Ethernet name, and the IP associated with it. The rest of the information is usually not useful for you. That's more for a network administrator. What you are usually interested in is, what is the IP of my system? This is the IP of your system in this case, and this is a network interface card. This is a command. So when you do a IP-A, you skim through the information, you try to find what you want. So you're looking at the Ethernet NIC name and the IP address. The rest of the information is not useful for you. You won't even understand it. Don't worry about it. Ping and IP. So basically you are pinging an IP, isn't it? This is what you are pinging. You can ping this one also. Ping. You're basically pinging the same server. It should respond back. You see the response back. Same server. Alright? Now that's a general IP address usually. Apart from this general IP, in this case you are looking at 172 something. Every system has this IP associated with it. It's called loopback IP. Every system has the same IP. Any system, including your laptop. Your laptop also will have this IP. So this is a loopback IP, means the same system. Every system has this IP. Apart from this IP, if you are connected to the network, you will have another IP also. You can be connected to multiple networks also. You can have another network card connected to the network, which means you will get another NIC in that list. All right? So that's your network. The route parts we will talk later. For now, these two are more than enough. Ping and IP. IP to find out your IP, ping to see whether a remote system is available or not. This is an IP that is available on all the systems. Let's move on to the other set of commands. ID, user add, password, groups. We'll skip through all of them. They're not immediately necessary. We'll move on to the next session. All those user groups, permissions related stuff. Let's move on to the remote systems here. Not okay. Sorry. I'm trying to finish the essential Unix commands today so that we can start Git from tomorrow. All right. All the things that are remaining in Unix, we will take up 10 days later. All user groups and permissions related things, we will talk later. They're not immediately necessary. This is important. Remote systems. All right. So far, you've been talking about a single system, right? All this time, you're working on a single system. But any project usually have a lot of systems. That's a distributed system. That's how everything can be increased or decreased, the size, right? So let's say you have just two systems. You can have a lot of systems, but we are talking two. Let's say this is server 1. From system, we move on to server. The terminology changes. They are also called virtual machines. Same terminology. All right? Start using this terminology. So you have VM1, VM2, virtual machine. All right? A virtual machine is basically virtual in nature, which means, let me give you a word example. This laptop, how many operating systems you have installed on it? 1. 2, you have 2. 1 you have. Usually 1. All right? Unless you have a dual boot operating system. Even if you have a dual boot, you can only log into only one. So right now, your laptop has either Windows or Mac OS. Right? On Windows, that Windows operating system is controlling your entire hardware. There are 3 pieces of important hardware you will always think about. CPU, RAM, hard disk. These are the only 3 pieces of important hardware you are looking at. A CPU is your CPU, i5, i7 or whatever it is. Then your RAM, you have either 6 GB, 8 GB, some RAM, there is a chip. All right. Then you have a hard disk, a 1 TB hard disk or a 2 TB hard disk. These are the 3 important hardware you always look at. Then there is a motherboard, other stuff, you don't really worry about it. What we are interested in is CPU, the power of the CPU of your hardware, the amount of RAM you have on your hardware, and the amount of disk space, it's called, or hard disk. All right. Now let's say they are really powerful systems you have purchased. You have an i7, i10, right? Now, a single Windows operating system cannot consume all the CPU power. Let's say you're just browsing. There's nothing much. The hardware is really powerful nowadays. The laptop hardware that we are using, it's actually server grade hardware. Means it's really powerful hardware. We don't do much on this thing. Nothing. There's nothing is done. All that you do is browsing, right? Nothing much we do. All right. Browser does not require i7 processors. Right? So what came up after a lot of advances in hardware? What happened is, why can't we run another operating system on top of this Windows. Can it be done? The operating system is a software, right? Which means it can be run as long as you write a software. So what happened was, so you have your original hardware. Let's say this is your hardware laptop. On laptop, you install Windows. On Windows, you install another system, another Windows, let's say, Windows inside Windows. This is not directly interacting with the laptop hardware. This goes through this Windows, which sends it to the laptop. So the original Windows is called host operating system, that is directly controlling the hardware. This is guest operating system. This is also called a virtual machine. There are softwares like VirtualBox, VMware, I think you are familiar with. These softwares basically allow you to create virtual machines on top of other operating systems. Just like Windows, you can buy another laptop. Host can be Ubuntu. Then you can create guests. Any operating system allows that thing. This is called virtualization. You are making the hardware virtual. For this guest, the hardware is directly not accessible. That's what we are talking about here. So let's say, for a practical purpose, you bought hardware of really powerful capacity. Let's say you bought i7 processor with about 10 cores. Each one is a processor. So you have a really powerful this thing. Then you put a RAM of 500 GB, not the 6 GB on your laptop. 500 GB. Then you have hard disk of 100 terabytes, or let's say 100 petabytes. Now you have a very powerful system. Obviously, you don't want to use it for browsing, right? So what you do is you put a lot of virtual machines on that hardware. You put some 100 virtual machines, each one having by 100 5 GB RAM, 500 GB total RAM you have. You are putting 100 virtual machines. Each one comes to 5 GB, which is almost equivalent to your laptop RAM. That's the original way. Usually you will see all this hardware being used in all real-time projects. But this whole thing is not known to you because this has been handled by the Linux administrator. So for you, you will get a virtual machine with a IP. So when you log into it, you're basically logging into a single server or a virtual machine. Well, let's get back to our Linux. So you logged into one virtual machine using its IP. Then you have another virtual machine with a other IP. Let's say this is 192.168.10.10. This is 192.168.10.20. I have to keep it simple. Let me put it this way. Let's say this is 10.10.10.10. This is 20.20.20.20. Now there are 3 or 4 things that you want to do. You want to connect from this system to that system. You want to transfer files from this system to that system. Alright? Connect an SSH, secure shell, to the remote IP, 20.20.20.20. That's how you connect from one system to another system. In Linux, if you are connecting from Windows to Linux, you have to use some tool like the mobexterm that we are using. Alright? Linux to Linux, SSH. Alright? Now when you connect to another system, you can't just walk into that system, right? Just like when you log in, can you get into somebody else's home without being permitted? So you need a permission to get into that system. The permission mechanism is usually implemented using username password anywhere, right? So SSH, user of the remote system and the IP. That's the general syntax. It goes to that system with this username. Then it will ask you for password. You give the password of the remote system, then you logged in there. Right? I'm going to show you that thing quickly. So here we are on a Linux system. I'm trying to connect to another system, SSH, with a username encode.it. The remote system IP is 192.168.12.101. This is a system available in the same network. All right. What's the username I'm trying to log in with into that system? Encode.it. Enter. So it's going to ask you the password of that user on that system. So if you know the password, you give the password. Once you give the password, you're on that system. You logged in. Once you log into any system, what are the 2 or 3 commands you run? First name, ID, uname, -a, IP, a. These are the 4 or 5 commands you run, right? Top, how much is available on this thing? htop, free-m, this is about 16 GB. I've executed the same 10 commands that we discussed. So we logged into another system, executed some commands. Yes, that system should be available. It should be reachable, means you should be able to ping to it. Then you should have the password of some user on that system. Obviously, if that system itself is not available, you can't log in. So that's simple. All right. Now that you logged in, once you log in, you are here. You are not here anymore. It's just like you entered somewhere else. Any command you execute is here. Now this thing you have to visualize always. SSH you have to visualize always. Once you do a SSH, you are here. All right? Yeah. What's the question?
System is also we can't have a
No, you can't. The system should be available and it should be reachable from this system. So you do a ping first. Ping 20, 20, 20, 20. If you are not getting a ping back, there's nothing you can do. Contact the Linux administrator, get it into the network. All right? Now that's SSH. Sometimes you want to transfer files from one system to another system, like the tar file that you did, d5.tar.zip. What we did is we unzipped it in the same system, but that's not the practical usage, right? Why would you want to do the same thing on the same system? You have copy-r for that. You don't do it on the same system. Usually, you compress and archive it so that you can transfer it to other systems and then uncompress, untar it on the other system. So here, on VM1, you have the file. You copy that file, securely copy that file. Compare it with your copy command. Copy source to destination. Same thing here. SCP securely copy this file. What is the destination in this case? A new server. Alright? 20.20.20.20.20. But because we cannot log into any server we want, we have to give a username. User, just like SSH command. User at remote. Now you said copy it onto the system. You have to say which directory on the other system, isn't it? When you say copy it onto the other system, you're not telling the location. You have to say the location also. So here, colon, let's say you want to transfer it into temp. So this file goes from VM1 into VM2 to this location. That's transferring files from one system to another system. This is a very common usage. Telnet, Netcat we'll talk about later. Any questions here? This is the important one. Remember this. Username @remote system colon the destination. This is what you usually miss most of the times. Colon the destination location. All right. Any questions here? This is when you have two systems. All right. Let's say you have a file on the internet. Your G drive, let's say. G drive, you cannot log in. There is no IP to it. But all the files on G drive have a URL, isn't it? Let's say you are trying to download something to a Unix system. How would you do it on a Windows system? How do you download it? You click download. It gets downloaded, right? Yeah. Because there are no clicks in Linux, we have to use some kind of command. There are two popular commands, wget and curl. curl, that is curl code. Wget, the file name. Let's say you have a file d5.tar.zz on your website, http encodeit.com/abc/xyz. Somewhere you got a path. Somebody gave you the path of a file, right? Or your friend has uploaded some files into the G drive and he gave you a URL. How do you download it here? wget the full URL. It gets downloaded. Or curl, again, same URL. Here you have to use -o output. Both commands are used. The curl is more advanced compared to wget. Let's try to download something quickly. I think we have it on our workshop. Linux workshop. Wget is not there. Curl is also not included. Okay. Let's see if we can download some file. So this is my G drive. There's a temp file here. This file should be accessible first of all. All right. It should have some kind of URL for that. So I'm sharing. Get link. So that's the sharing done. This is a link. I'm copying the link. All right. Now go back to your Linux system here. wget. That's a URL. I'm not sure if it will come down or not. That's it. Yep, you got it. It says, let's see what happened. So this is wget. This is a URL that I got it from G drive. So it basically connected to that whole thing by resolving the IP. It basically connected to the same Google Docs. You see this? docs.google.com. This is the same server that we got when we pinged google.com. All right. Then HTTP request sent to download. Waiting response. 200 is good. Then length, blah blah blah. It's saving to so and so. This is the details of how long it took. It took about 0.07 seconds to download it. It downloaded at about 4 MB per second. So let's look at our file. Let's type in ltrh. That's our file. Now this file's name is really ugly. We're going to change it. How do we change the file name? Move into my file. dot, because this is a G sheet, that's my G sheet. I just have the G sheet here. There is no software on this system to open the G sheet. That's another problem that we'll see. Alright, so that's for downloading something. You can use curl also to do the same thing. Let's get the same URL. Instead of wget, you can directly use curl without any -o. It will still work. Curl. It actually downloaded the contents. So curl -o -o capital O. This it downloaded. All right. ls-ltrh. This is a new file that's downloaded. You can rename it to whatever you want. All right. So you have either wget the URL or curl -capital O. All right. These are the two commands. Why do we use them? To download from the URLs. You have a URL, you don't have a file, so you want to download it. Like Windows, you double click download and it gets to your system. On a Linux system, when you have a URL, especially from internet, you will either use wget or curl to download it. Right? Now let's look at the next thing. It's done. What's our next commands? Redirection. That's again, let's talk pipe, not the redirection. Instead of pipe, we will talk. No, redirection we'll talk later again. That's also not necessary. Let's talk grep. Grep is a one. Grep is a command. Take an example of, let's say you have a text file, all right, and there are about 100 lines in it. Each line has a name and other information associated with it. Take the role of your college friends. All your friends list is, let's say, is stored in a regular text file. A name, which branch, which stream they are into, all right, their birthday, let's say these three information. So you have, let's say, about 100 such rows. Out of all these rows, let's say some of them have same branch, obviously, all right. Now assume all your batchmates list is available in there. Let's take 4 batches, 4 streams: computer science, electronics, electrical, and pick up anything else. Chemical, let's say. All right. So you have computer science, electronics, electrical, chemical. All right. These 4. So there are 400 students listed in that file. Now you want to filter out all the students who are in computer science. If it is a Windows system, what would you do? You are given a file, text file, which has 400 lines in it, each line representing one of your batchmates. Now you wanted to list out all the students from computer science. How would you do that? You have a filter command in Windows? If it is there, let me know. It's really difficult. So how do you do? Search. Searching will only give you search. You need everything else, all that list at one place really quickly. What would you do now at this situation with your current knowledge? You open the notepad, browse through each line, see it manually, copy it, paste it into another notepad. Is there any other way you can do? Hmm? Average. What's average? We're just listing out. It's not. We're not looking at any calculations here. I just need the names of all the students from computer science. That's all I need. Let's say you are hosting a party tonight. You just want to invite the computer science guys. How would you do that? Hmm? But what's the command to do that? You need a software to do the matching, right? How can you do it in MS Office? Excel, how can you do it? Ah, yeah, that's right. So you need some kind of software. Windows natively does not have such a thing. Can you do it on a Windows operating system level? If you want Excel, that's a different software, MS Office. You have to install, all right? So Windows does not have it, whereas Linux has something. grep basically grabs it. It just picks up things from files, any file, for a keyword, anything you want. So in your example, grab computer science from the file. It lists out all the lines that have keyword CS in them. Now, obviously, sometimes you do a small letters, sometimes capital letters, sometimes small and capital, sometimes small and capital. You don't really know the case of it, so you ignore the case using -i. This is the most popular command. Grep, ignore the case, search for the keyword from the file. Or grep, ignore the case. This is a keyword. You can give any keyword you want. Let's say you want to search for ABC. Grep searches line by line. So you have, let's say, 100 lines. A grep goes through each line and sees if this keyword exists or not. If it exists, it will filter out. Right? Now the grep command can be used little innovatively. For example, ls-ltr, what it does, it lists out everything in a directory. Now you can transfer the output of this thing into another command using what is called a pipe. This is another thing in Unix. It is not available in Windows. So what a pipe does is, this is a pipe. So it's usually next to your enter bar, above the enter. So here, you see, this is pipe. Can you see that? You see that? Pipe. This is the one. It's above your enter keyword. So here, let me see that. ls-ltrh pipe. So what I'm doing using this pipe is, instead of displaying everything onto the screen, I'm sending the output of that command to the next command. If the next command can take this input and process it, it will be able to do it. So in this case, I'm sending it to grep command. What grep normally does? It greps for a keyword, either in a file, or if you are not giving a file, in the input that it is getting from another command through a pipe. You can pipe it as many as you want. So output of one command going in as a input to the next command. You can use as many pipes as you want. That's what makes your whole Unix thing really, really powerful. All Unix commands can be piped. ps-ef grep for bash. I want all the lines in the output of this thing that have bash keyword. Alright, for example, ls-ltr, let's say, we have some files here which are having this keyword Ansible. I want to filter out only the lines that have Ansible keyword in this case. How would I do that? ls-lt or h, pipe it to a grep command Ansible. Alright? That should list out only lines that have Ansible in them. Now that's the fastest way to filter anything. Or ls-ltrh grep for, let's say, F1, I think we have. F1, I don't know. ls-ltrh. Okay. Vagrant, let's say I want to pick up Vagrant. ls-ltrh grep for Vagrant. There's only one line. Let's say I want to pick up for VirtualBox, but I don't know whether V is caps or small letter. So here in this case, ls-ltrh grep, let's say I did a virtual. Alright? There's nothing that says virtual. The reason is V was caps in there. You see this thing? V was capital letter. And because we did only grep without any I, it searched for the exact word. Now if you don't know whether it's capital or small, here and here, what we are doing? Grep hyphen I. So grep hyphen I don't know whether V is caps or not, so I don't care. Just give hyphen I from ls-ltrh pipe it. Now, irrespective of V is caps or small, without even knowing it, you get that line. Alright? That's your grep command. Then find, sed, awk, they will come later, a little advanced commands. Yeah, I think that should set you up for the basic Linux. Yeah, I'll stop it here. We'll move on to the workshop. Any questions? Let's filter out the IP address from that ugly output. IP-A. This is the ugly output everywhere. You don't like it, kind of. You have to search through it, right? So IP-A, grep for the line that has your IP usually. inet is the line that usually has your IP. You see this thing here? Your IP is inet. So every time you want to see this line, you just grep for inet. So now you have all the lines that have inet. Now out of this, filtering is easy. You're basically looking for this IP. That's your actual IP. There are other IPs. They are not really necessary. When you see those IPs, you will understand. One of them is this one. The first one is a loopback IP. Alright? So grep is a really powerful tool. It makes things a lot of easier when you're filtering out things. Right. Any questions? Unix commands are just like tables. You just have to practice them. There is nothing more to understand. You understood it, everything now. That's all. There's nothing beyond it. You get comfortable with it only to start using it. Alright? So the recommendation is to mug up those commands. Just remember that list of at least 50 commands. How long does it take to mug up 50 items? 10 minutes? We're all good with mugging up. Don't tell me otherwise. Alright, so we'll stop it here for today. We'll continue with the workshop. Sampurna?